Hello, and welcome to another episode of The Message from Deep Space. I'm Alex Rose, aka Sapien, and we are on week 26. So, last time that we were here, we learned more about grammar. We established a word that is some commonality between aliens and us. We also established words that let us talk about sentence structure. So, was created to be semantically different from equals, or we can define a quality that something has. Adjective will change a noun in some way, and a preposition will change a thing's role in a sentence. So, you got any English teachers, and you want to try and convince the value of this game for them, just tell them that not only are you learning an alien language, you are learning grammar itself. Okay, so we're starting with a pass through. A pass through, and then one atom, and a visual. Ooh, let's take a look at the picture the alien sent us. Well, I guess I don't know what I expected. It does say it's one sphere. So they're saying though this yellow sphere is equal to one. I believe that is a carbon atom. If we take a look at our periodic table, that is carbon. So one carbon atom. Fair enough. All right, we're establishing that that's carbon. I'm assuming you're gonna paint us a more complicated picture here now with some of this. Okay, this is one helium atom. Okay, thank you for defining one helium atom. This is now, and okay, so suppose atom of some value is not atom 1 or atom 6 or atom var 0. How can atom var 0 be not atom var 0? Uh, Equals molecule, therefore cluster. What does this mean? What on earth are you talking about? So if atom var 0 is not equal atom 1 or atom 6 or atom var 0, uh, or atom var 0 equals molecule, uh, and I'm assuming that this not is affecting this whole statement. Um, well, they're just giving us a pass through, but I think they're telling us that that is an atom that is not a molecule. So that's just some other atom. So sure. Uh, okay, we have a carbon and 4 helium. I don't think that that's technically allowed with valence electrons, but sure. Um, well, maybe it is. How many free valence electrons does carbon have? Um, Valence electrons. Uh, so they're grouped by the number of valence electrons. Elements within the same group share similar chemical properties. Um, so only electrons in the outermost shell can be shared via bonding. So these have one valence electron. These have one, two, three, four. Is that how we're counting it? Or yeah, that must be it because they just showed us an atom with four uh, valence electrons. So uh, four atom one, one atom six. Sure, that makes sense. Okay, two carbon, three helium on that side, three helium on this side. So this is uh, dicarbon six helium. Um, so they're asking the same thing. So this is six atom one, two atom six. All right. Now they. Oh. we're creating a slightly more complicated chain. So this is 3 carbon, and then 6 helium on that side, 2 helium in the middle. So this is going to be 8 atom 1, 3 atom 6. As long as they keep drawing us the picture, I'm good. That's much easier than counting valence electrons. Okay, this is a very big structure they're defining here. It looks like a carbon chain. They're going through a lot of effort to visualize this. I believe this is diamond. A carbon lattice like this. So molecule 0 is 68 of atom 1, 33 of atom 6. So they are... Are they attaching helium here? I don't see any. Well, let's think about how these are structured. So if each of these is connected to 2, that means they must have 2 helium on the back. Because these are not touching each other, they're not overlapping. Well, we know that they're looking for atom 6 because this is carbon. They've told us to remember that. We're too zoomed in. This is unstable because this carbon is donating 4 valence electrons away, but these still have 5 valence electrons each at that point. So what's up with that? Molecule 0 is something atom into this, and it's weird that the number before that is undefined. Like they're putting a lattice on it in some way. Okay. So, some quality, some adjective is this signal. Suppose molecule 0 dot 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 atom 6 dot dot dot. Therefore, molecule 0 is we could say organic because that's how we define organic, is if there is carbon in it. Organic, as in organic chemistry, I presume. Yeah, that's correct. So suppose molecule 0 contains carbon, therefore molecule 0 is organic. Suppose molecule 1 has 4 helium and 1 carbon, therefore it is organic. Suppose molecule 0 is organic, therefore molecule 0. So this is how they did it, like dot 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 something carbon atom 6 dot dot. Okay, so molecule 0 contains 4 helium and 2 of atom 6, therefore molecule 0 is organic. Organic molecule target aliens make with. Okay, so they're carbon-based life forms like us. That's nice. It would have made Grace very disappointed, but he's not here, and we are. Okay. So, suppose molecule 0 contains helium and some other stuff. Therefore, molecule 0 is something. Okay, so we need another chemistry word, and I don't know another kind of chemistry. So we have acids, we should have a word for something that contains. I've been saying helium. I meant hydrogen this whole time. What a fool I am. Um, so acres define things that are only helium and hydrogen as non-metals. Now, we have this new word that uh, that means that something contains hydrogen, but we don't know. I don't know a word that means contains hydrogen. Um, Surely there is one though, because it seems important. Like, okay, a cursory lookup in the dictionary, in our real dictionary, says that we use the word hydrogenous, which good enough for me. Um, so they they are also hydrogenous, um, which I think probably implies that they're water based. So molecule 0 is 12 of hydrogen, 6 of carbon, 6 of oxygen. Um, okay, molecule 1 is oxygen gas. Molecule 2 is carbon dioxide. Molecule 3 is uh, uh, dihydrogen monoxide, which is water. Uh, is it? Wait, no, that's hydrogen dioxide. This is dihydrogen monoxide. Probably an important differentiation. Okay, so 1 of molecule 0 and 6 of molecule 1. So these two together, reaction molecule 3. And reaction produces 6 of molecule 3. Oh no, we're balancing chemical equations. No, this is my nemesis. Um, okay, so if we have 1 of molecule 0, we have 12 hydrogen, 6 oxygen, 6 carbon. And we are combining that with 6 molecule 1, so that's going to add 12 more uh, oxygen. So we're at 12 hydrogen, 18 oxygen, 6 carbon. And our output is producing 6 of these. So we'll take away 12 hydrogen and 12 oxygen, and 6 oxygen. So that empties our hydrogen pool, and that reduces our oxygen pool down to 6. Um, so that leaves us with 6 carbon and 6 oxygen. Um, Now, molecule 3. Now, okay, we don't have a molecule 4 to define here. So what do they want us to do? We could define a molecule, or we could just say 6 atom 6, 6 atom 8. No? Okay. we could define a molecule. So they would need to be in equal quantities. So we could say 6 molecule, atom 6, atom 8. And if this doesn't work, I'm going to check my math. No, I'm going to check my math. I know you have ideas. I will listen to your ideas in 1 minute. Okay, checking my math. We have our recipe of 1 of molecule 0, 6 of molecule 1. And so that gives us 12 hydrogen. Carbon is 6, and that's it. Wait, 1 of molecule 0, but yeah, 6 carbon in the molecule. And oxygen is, we're going to start at 6, and then we add 12 oxygen. So, like I said before, that brings us to 18 oxygen. So we have that much. Now we are producing 6 molecule 3s. So 6 molecule 3s are equal to 12 hydrogen, which is again what we said, that it gets rid of our hydrogen, and 6 oxygen, which again, now that doesn't give us an equal quantity of carbon and oxygen. That brings our oxygen down to 12. Because this molecule 3 only has 1 of this oxygen, not 2. So that means we have 12 oxygen, and 6 carbon, which means that we are making carbon dioxide. So we can clarify like this. Okay, we can also just say 6 atom 6, 12 atom 8. I don't know if that will be specific enough. Not quite. So there's nowhere else that we define carbon dioxide, right? Wait, yes we do. We define it here. Molecule 2. So we can just say 6 molecule, 6 molecule 2s. Okay. Not bad, but I'm assuming it's going to get worse. Okay, molecule 0. So now we are balancing equation once we are given a reaction and know the output. So we're saying that molecule 0 is part of our output, and we produce 1 of it along with 6 of molecule 1, which is oxygen, dioxygen. Molecule 2 is atom 6 and 2 of atom 8. So that's oxygen dioxide. And then molecule 3 is oxygen dihydrogen, dihydrogen monoxide. And is that, I feel like a H2O is water. So that's hydrogen dioxide, right? But like that feels silly. No, because the 2 is subscript for the hydrogen. It is water. They are talking about water. Oh, Acres, you would have been able to tell me that. Okay, so they produce 6 oxygen by combining 6 oxygen and the molecule 0, which is our our output, our side effect, um, by taking 6 of molecule 2, which means we have 6 carbon and 12 oxygen, and we have 6 of molecule 3, which is 2 that's water. So we're doing 2 water or 6 water and 6 uh, carbon dioxide, and we are outputting oxygen and some amount of carbon and hydrogen and oxygen. Um, because these are our inputs. So the fact that we have 6 output here takes all of the oxygen, meaning that we are left with our 12 hydrogen and our 24 carbon. So that's going to be 2, 12, and 24. I want to say 12 molecule 0. No, 1 molecule 0. But molecule 0 contains the entire output? Is that true? Is that accurate? Is that what it's asking? Yes, because this is the oxygen. It's sucking up all the oxygen in the room. We have 12 hydrogen. And we have 24 carbon. So, this feels like a big molecule. Okay, that was wrong. Now, I'm gonna start balancing numbers again. Okay, so molecule 2 contributes 12 carbon. Molecule 2 contributes 12 oxygen. Oh, okay. So it's not soaking up all the oxygen in the room. So it is this plus 6 atom 8, I believe. Nope. Okay. I'm pretty sure I know that I'm just doing the math wrong here, but I'll listen to whatever ideas they've got. Molecule 0 is some organic compound. Molecule 1 is oxygen gas, molecule 2 is carbon dioxide, and molecule 3 is just water. Why does this look so familiar? This seems to be the inverse of the last transmission's recipe. Oh, is it? Am I the fool? You know, I don't want to. I would love to not have to balance this equation. Because yeah, this is 1 molecule 0, which is 12 hydrogen, 6 carbon, 6 oxygen. Okay, I vastly got the amount of carbon wrong. That's okay though. Okay, so we're given a bunch of recipes. And recipe 0 equals something recipe 1. Okay, so recipe 0 is taking 1 molecule 0, 6 molecule 1, and using a reaction to get 6 of molecule 3 and 6 of molecule 2. Recipe 1 is, I'm assuming, the inverse. 6 of molecule 3. I'm going to change molecule really quick because this is beginning to get annoying. Molecule should not new line the start, I think. Maybe it should new line the start. This looks horrendous. Therefore should new line though. Where's therefore? we defined that a while ago. Okay, I am gonna go back to having molecule new line, I think. This looks worse. Unless we wanted to have open and close parenthesis new line. We try it. New line before. And close parenthesis, new line after. I don't like it. I'm reverting. I'm reverting most of this. So we undo our parentheses, and our molecule we also will take back. We will new line the start of molecule. And we'll live with the fact that it gets orphaned up at the top. Okay, therefore recipe 0 equals... Do we have a word for opposite? Or for inverse? I think we do. We have opposite. Okay, recipe 2 is one molecule that is atom carbon dioxide, something, reaction, one molecule 4 of atom 1. Okay, so we're back to balancing equations. And so the output is 4 hydrogen and 1 carbon. And then the ratio here is 4 hydrogen and 1 oxygen. So for every 8 hydrogen, we get this reaction. So here we have 2, we have no hydrogen. So we need 8 hydrogen. Now, this gives us 2 carbon and 4 oxygen per this equation. So the output produces twice as much oxygen as carbon, and our current ratio is twice as much oxygen as carbon. So our oxygen to carbon ratio needs to be maintained. So we're currently bringing in 4 oxygen, and we're currently outputting 4 oxygen. So we can't add any more oxygen. And we are currently bringing in 2 carbon, and we are currently outputting 4 carbon. No, we are currently outputting 1 carbon. So the fact that we are producing 4 oxygen here, we have 4 oxygen here, and we are making 1 carbon here, we have 2 carbon here, means that we actually need to increase our oxygen ratio, perhaps? So it's a pretty specific number, though, because they're saying 1 of this molecule and 2 of these molecules. So, or no, yeah, reaction produces 1 molecule, 2 of these molecules. How do we end up with less carbon than we started with? That doesn't make sense. So, what? molecule 4, atom 1? That doesn't even make sense. You can't do that. I guess you could have 4 of atom 1. No. Okay. What ideas do you guys have? I'm open to it. These are not for this one, but these reactions, they're familiar. The previous 2 transmissions. Oh, okay, so something that's in the reference tab, common reactions. Yes. Cool. What ends up with 4 hydrogen and 1 carbon? That would be great to know. No, no, okay. Synthesis of water, no. 2 H2O, and no, too much to hope for. Now, hold on. This H2CO3 produces carbon dioxide. No, but not 4H2O or H4C. So we're looking for. Is that all you got in terms of chemical reactions? Looks like it. Okay, I'm gonna clear the ideas, and I'm gonna take a look at them in the log. Yeah, 8 hydrogen. Yeah, 8 hydrogens are missing from the left side of the reaction. So is that the answer? Unsure. Oh. Perhaps this? It is unknown how these atom ones are arranged. It could be 2 copies of a molecule with 4 of atom 1, or 4 copies of a molecule with 2 of atom 1, or 8 copies of atom 1 to be seen. I think it would be 8 copies of atom 1 because you don't make a molecule out of 1 atom. No, okay. So wait, but things don't react with helium. This doesn't work like this. No, hold on. That's crazy. Because 2 hydrogen. No, 2 hydrogen is not a helium. Helium has. No, wait. It's. I guess it's not, because they're not. The protons wouldn't be in the same nucleus. Okay. Okay, so their recipe count is still going up. So they're defining chemical reactions for us to reference. So 3 oxygen, and something 18 molecule with 2 hydrogen and 16 and atom 16. What's atom 16? Sulfur. Interesting. What do we do with sulfur? Do something with sulfuric acid? I don't see a reference to sulfuric acid here. It's fine. We wouldn't be prepared for everything. So, if we have 3 a molecule, this, and something, and 18 a molecule, this, then we form a reaction that produces these 3 molecules. So, the sulfur seems to be we bring in 18, we put out 18. Sulfur is balanced. We bring in 18 hydrogen here, and we output 12 hydrogen here, and 12 hydrogen, and 24 hydrogen here. So we need 18 more hydrogen. By my count. Because. No. Sorry. I forgot this two up here. 36. So the hydrogen is balanced. So that leaves oxygen. We bring in 2 oxygen up here. And we put out. No, we bring in 6 oxygen up here. And we put out 12? 13? It's a weird number. Is that correct? 3 oxygen here. And no oxygen here. So that does make 13, which means we bring in 10 oxygen. So that's going to be 10 oxygen and what? 10 oxygen. We have carbon, and we didn't bring in any carbon, right? So oxygen and carbon like to form carbon dioxide. We have 6 carbon along, so 6 carbon to complement our 18 oxygen, which could be carbon dioxide, or I think we have a ratio of 6 to 15, which makes me want to say something like 3 molecule, 2 atom 6, 5 atom 8. No. Okay, let's count the oxygen again. 3 oxygen here. That's it. And we have 6 oxygen here and 12 oxygen here. So that's 18 oxygen minus 3. That is 15. And we have 6 carbon. And my current response is to have 6 carbon, 15 oxygen. So that would match. But perhaps they need us to do something more complicated and try out the full molecular structure here. No. Alright. So, lots of atoms. Atom 1, atom 6, atom 8, atom 18. Translate these as hydrogen, carbon, oxygen, sulfur, yes? Yes. Struggling to find anything matching this recipe in the reference tab. Then find which atoms are missing, which remains one of your skills. So tell us, what have you figured out? Left side has 36 hydrogen, 18 sulfur, 6 oxygen, and a missing molecule. Which is what I have as well. Right side has 36 hydrogen, 18 sulfur, 18 oxygen, and 6 carbon. Correct me if I'm wrong, but that means we're missing 6, and I'm 6. Am I 12? Am I crazy? I must be crazy. Yes, I'm crazy. Maybe I shouldn't be new lining these things. Maybe it just makes me feel crazy. Fine. It will be harder to read, but it will actually be more accurate to read. I'm gonna fix the molecule and atom again. So molecule, don't new line the start. And atom, don't new line the start. And the answer is 6 molecule, 6 atom, 6. I think we usually do highest first. 2 atom, 8, 1 atom, 6. No, wait, we usually do lowest. I don't know what we normally do first. 1 atom, 8. 2 atom, 8, 1 atom, 6. Stop making me do O-Chem aliens, please. No. Oh, no. No. It's the wrong order? Have I displeased you with my order? 1 atom 6, 2 atom 8. It was my order. I think we always do the smaller atoms first. Not the ones the smaller quantity, but the actual smaller ones. Creature target recipe 0 reaction. Wait. Creature target. Wait. Are they defining what it means to be alive? Because they were defining these recipes as bringing in molecule 0 and molecule 1 and producing molecule 3 and molecule 2. I think it's alive. Perhaps. But I thought we defined it as a noun. What did we define that as? Okay, yeah. What did we define that as? Hold on 1 second. And we're back. Okay, so this is the formatting they've used to define a proper noun before, where they jump up like 50 from where we are. And if we look at our dictionary, what is this right next to? 144 is not right next to their planet or their star or our planet. It's more on their side. So it is a creature, target creature. So it's something that a creature makes with another creature. Something target aliens 1 make with. Is it what? I don't know what. Contact? They're saying humans. No, not humans contact aliens. Aliens 0. Okay, that's why there was a 1 at the end. Because contact equals something target creature make with. And they've drawn us quite a big picture here. Is this a different alien species? Is this DNA? That looks like DNA. That looks like a double helix. Uh, that looks like a double helix. But that's crazy because we assume that we would have a common ancestor because everything has DNA. But DNA is not the only way for genetic information to be structured. Because, I mean, even on Earth we have RNA. So, contact equals... So, it's not contact, it's like... It's genetics? It's a baby? Aliens contact equals 2 aliens. Target 1 aliens make with. So aliens count equals 4 because there's the 3 initial aliens and then 1 new one? No? Okay. Or wait, these 2 aliens is the target. Make 1 alien. So make 1 alien with 2 aliens. So I think they might be talking about sex. I have a surprise for you 3. Is it another Employee of the Week celebration? I don't think we're in the mood, Dr. Doppler. No, but have the aliens discussed any more astronomy? 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 Ahem. Guess who's back? Alan! Good to see you. I knew it would be. I take it back. Hey! Glad you're back with us, Akers. Dr. Rose will catch you up to speed. But first, we must know, where do the aliens live? Have you found their home? Well, we have good news and bad news. Well, let's start with the bad news. I haven't found anything matching their star in the stellar catalog. I didn't even consider that a possibility. So we don't know where they live. What's the good news? What? Oh, yeah, there's no good news. I just didn't want to say it was all bad news. Akers. Can't we point a telescope in the direction and find it? Well, they gave us no angular data. It's rather difficult to describe directions in space. They could have made a map using neutron stars and pulsars, though that's highly advanced and only recently discovered for humans. I trust there's a good reason they stayed away from that. I see. Unfortunate, but we can sweep the skies searching for it. I'll get the stars data to every observatory in our network. Even foreign research organizations, volunteers, amateur astronomers, whomever. Well, that'd be like searching for a pebble in the Pacific. With enough divers, we'll find it. But that raises another concern. The star may be too dim to observe with any modern telescopes. Too dim. Even if we were looking dead at it, we wouldn't see it. Even with our strongest telescopes, it's still a grave possibility. What are we gonna do? We just have to get lucky. Hopefully it's visible, and your big wide search will find it. If not, we'll wait and see if we eventually find a star that matches. In the coming decades, we'll make bigger and better telescopes. We'll catalog more and more stars. And one day, we'll map up the whole Milky Way. We'll find their star. It's possible that could take decades. I know. But you said it yourself, Doc. Our spirits will live on through the future scientists that find their home planet. It was Sir Isaac Newton himself that said, if I've seen further than others, it is by standing on the shoulders of giants. And we've got an opportunity to be those giants. You know, it's a good spirit, Dr. Akers. Only 3 words this time. And too much work doing chemistry. I mean, we created a library of organic reactions that are probably useful, but they were boring. Okay, Alan Stroh. Driven. I came back empty-handed, but I'm refreshed and ready to press on through the translation. We'll learn everything we can about them. Batista Slug. Mm. Dear Diary, a month ago, we feared the alien message may surpass human science. We feared it may take decades to progress to the translation. It may take decades to find their star anyway. To send a return message. The translation team has found the tools for future humans to find the alien planet. Whether it's tomorrow or 50 years from now, humanity will find them. I think the aliens were talking about sex. And why do they have DNA? Okay. No, no word for the last one. No guess on the last one. Oh, and that's Act 6. I'll see you all in Act 7. Oh, it's red now. All right. Well, that is where we're gonna leave for today. And if you actually, that's not where we're gonna leave for today. We're gonna really quickly go into the dictionary, and we're gonna see if this is sex. Really? How mature? At least you demonstrate maturity, Batista. Oh, not you too. I think I might be right. I think I might be right about that one. All right. Well, as always, if you enjoyed, don't forget to like and subscribe, and I will see you in the next one.